Hello and welcome everybody to the 2:30 session. My name is Mike Weimerskirch. I am the Director of Educational Innovation for the University of Minnesota's School of Mathematics Center for Educational Programs. And today I'm going to talk to you about a project that we have worked with Wolfram on, using webMathematica as the engine to deliver homework to students. Specifically, the name of this project is the Minnesota Online Learning System, MOLS for short. MOLS is delivering randomized homework and quizzes to 1,600 pre-calculus students, including, as I speak, I have 250 students taking an exam right now. This also houses our placement exam that over 7,000 students each year coming to the University of Minnesota take in order to get placed into introductory level math courses. So what is MOLS? What is the modern day approach to students doing homework? We've gone away from pencil and paper, as most everybody has, and we now have a computer system. And all of these things are all pretty much the same. They have four components. First off, you need some content. Somebody has to write some questions, and they need to be made available to students. Once the student is presented with a question, they need to have an interface where they can answer the question. Once the student has submitted an answer, something needs to determine whether or not what the author proposed as the answer key and what the student proposed as the answer are the same mathematical object. And then the instructors need to know how well the students performed on the assessments. And so these are the four parts that we tried to build. So how did we get here? In 2013, we decided that we would flip the pre-calculus classroom. Pre-record lectures, students watch those at home, do homework in class. Except we didn't actually flip the classroom. We did some other affine transformation to the class that I need a cool name for. There's a better idea than just working on calculation. Instead, let's also do the homework at home. Let's watch videos and do the homework at home, do the skill building, and then use our class time to do some other things. The things down here at the bottom of Bloom's taxonomy: learn a procedure in order to perform a certain calculation. Those are important skills to have a foundation, just as spelling and grammar are important for writing. But that's not all there is to good writing and math. There's more than just the computation. We have wonderful tools now like Mathematica that do a great job at computation, and we need to spend more time with students up here at the upper end, working with the higher order thinking skills, working on problem solving and communication. Most of the time that I give a talk, we talk about the pedagogy and what we're doing in the class. Except here today, we're more interested in the other half of my class, the part that I don't really deal with. Watch videos, do some homework. How can we have a tool like Mathematica help the students learn those procedures, evaluate how well the students are doing on that, and help the students learn by pushing as much as we can over to the computer side, let the computers do what they're good at, and let the teachers do what teachers do best. The first year, we used a publisher's product, and it took about a year to realize that we needed something better. So we started looking around. We were using Pearson's My Math Lab. It cost students $109, caused some problems in the fact that students have delays in financial aid, and so they don't have the product right away, and so they can't really begin class for a couple of weeks, and they forget their password, and all those technological issues that just stand in the way of teaching. Plus side, in one sense, if the professor doesn't want to put a lot of work into it. You get a product that's what you're going to use. You don't have to think much about it. You just send students off to do some homework. You don't really worry about the content. You just go right along. One downside I saw to that is that the questions that my students were doing were questions that the publisher wanted them to do, not the questions that I wanted them to do. I wanted to have some local authority as to what it was that I was asking the students. There also were some issues with the interpretation, this evaluation engine. One of the notable cases was asking students what the sine of 330 degrees is, and my students say, that is a fraction whose numerator is -1 and whose denominator is 2. And the system said, no, that is wrong. It is a negative number that is a fraction whose numerator is 1 and whose denominator is 2. The system didn't recognize these two things as being the same, leading one of my TAs to taunt the system saying, come on, my grandmother can parse better than that. So we needed a better system. WebWork, MAA project. It's got a lot of positive things to it. It's free to the students. You do need some server space at your institution in order to run it, but it's open source. I can grab the wonderful question bank that Gavin LaRose at Michigan wrote and start using those questions. And it works well for a certain part of our population, but it's the part of the population that's already well versed with mathematics. They need to learn a lot of syntax. You just have to know that SQRT parentheses is the thing you're going to need to do for square roots. You can write your own questions in WebWork, but you pretty much need to be an expert in programming in Perl, which I am not. I am a low-level programmer. And so we needed something easy for instructors to add content to. A third thing we looked at the time, 2014, we were a Moodle school. And there's this product, Chris Sanguin and others over in England, an add-on called Stack. Again, free to students, which we like, open source, which we like. Again, students needed to learn some syntax in order to input answers, but had a lot of neat features to it, kind of a lot of good innovation to it. Once again, you had to be a pretty sophisticated programmer to put content in. And the one thing that really drove us away from our technical people's viewpoint was Moodle wasn't going to be around for much longer. And it turned out they were right. Minnesota switched to Canvas in 2018 and is no longer supporting Moodle. So we needed something better. And I stumbled upon this. I stumbled upon the Wolfram Alpha Pro problem generator. Looked like it had a couple of the components that I needed. There's a question bank. Didn't have a lot of questions in it. That was going to be a problem. But I could take care of the authoring if the authoring were simple enough. And there's a student interface. Looks pretty nice. Mathematica, a wonderful engine to determine whether the student answer is correct. And then we just had to figure a way to spit out the gradebook. So after talking with the Wolfram folks for a while, we went forward with this project. Anshu Manik, now Calvin Michaud, managing the project. We worked with Chad Knutson for years. Now Danny Finn and Victor Pang are helping us with this project. And it's been a wonderful project for us. So here's what we have. Question authoring. At Wednesday's night award presentation, Stephen Wolfram talked about how I would have an idea in the morning and be able to put it into action quickly. And that's a fairly common story. I want to get something going right away. I have an idea and I can type something up in a few minutes, upload it, put it in an assignment. I can have an idea at 8:30 and be able to implement it in my classroom by 9 o'clock. Fairly simple system. You can define random variables. You can define an integer in a certain range. You can pick randomly from a list. If you want to refer to something a little simpler that has a multi-step process, I can define further variables. I want to talk about red ping pong balls and blue ping pong balls. and the total, so I can talk about the total ping pong balls and do that computation off of other random variables. And then you just start typing away. A lot of this is text. Some of this is Mathematica code. You can embed graphics. We even have a few questions that include manipulate in them. And there's a question. Show the answer. Students can go to work. Or you can be a little more sophisticated. I've learned a few tricks to kind of keep the questions that I want. One of the problems with Mathematica is that it's sometimes too good at its job. If I write this fraction that has x minus c in both the numerator and the denominator, Mathematica will realize, oh, I can simplify that. And I don't want it to, because that's the point of the question. I want the students to factor and simplify down here. So a few tricks to keep things looking the way that you want to do it, but didn't take me long. Font size so that it is readable down here. And here's a question that's displayed to the students. Or go crazy. Here is fairly sophisticated code that produces random graphics. Here's a question, solve a triangle. Warning, this picture is not necessarily to scale. No, it is. This picture is the correct picture because the coding took the parameters and drew an appropriate picture. So do as little programming or as much as you want to make things look however you want. Students need to be able to answer the questions. We've worked on a palette interface. Some improvements could still be made here, make this look a little prettier, but it does the job. We don't get a lot of issues with the students. We work out a problem. The answer is going to have a square root in it. The student just hits the square root button. Yes, you still need to have the Mathematica code in your answer blank, but by hitting this button, you get what you need. You get SQRT and the brackets. You need to move your cursor in here so you can start typing that. Once you come outside the box, it'll show you what it thinks you've written. So students here will often, oh, they missed the parentheses and the 45 is only on half of this expression, and they realize they better put some parentheses in here to get what they need. Students have been pretty capable of figuring out how to make their answers look like the way that they need them to and write the math that they need to. We need to determine whether what the student wrote is correct. One of the things that we kind of finesse past the students but would like a solution to is sometimes Mathematica is too good. We ask the students what the sine of pi over 6 is, and I'm hoping that they've memorized the unit circle and they'll answer 1/2. They could type in 0.5, that would be fine, but I can make them be specific on sine of pi over 3. They need square root 3 over 2. They can't use a decimal approximation. But they could also just type in the question. They could answer sine of pi over 6, and Mathematica would know, yes, the sine of pi over 6 is 1/2, and that does match what the professor wrote down as the answer. And so we're looking for some ways that we can specify certain forms that are allowed on certain types of problems. And here's the grade report that the student gets back. It shows exactly what they typed in. It shows how the answer got interpreted. Notice that Mathematica did do this much. The square root of 32 got simplified to write a better expression. This is sometimes a good teaching moment for the students. They see that what's parsed here is different than what they typed, and they may now realize, oh yeah, there are rules for simplifying square roots. This winds up being a pretty good teaching tool as well. Compare to the correct answer and they can see what their mistake is. What types of things can we ask students to do? We can ask them to input answers which are numbers, which for me in pre-calculus, I by and large mean a real number. but it works equally well for complex numbers. Research-wise, I did my PhD thesis in combinatorial game theory. So just for fun, I think it would be kind of cool to John Conway, Donald Knuth, surreal numbers, and Berlekamp, Conway, and Guy, the games. If we could do computations on games as a bigger set than numbers, I think that would be pretty cool, but that's just for fun. For the teaching purposes, mathematical functions are important, and it can tell whether one function is equal to another function. You can use text strings as the way that you're evaluating the answer, though that's not very useful. The answer might be x plus 2, and the student types in x plus 2, and it sure did sound like I said the right answer, but you didn't realize that I left a little pause in there. If the cursor isn't in the right spot and there's an invisible space showing up in the character string, then it gets counted wrong. So we don't use that very often. We do have the ability to take multi-part answers. So if the answer is a set, we can handle that case, though it's not quite as nice as we'd like it to be. We don't use the squiggly braces the way that students would typically write sets. You just separate things with commas, and they have to learn a little bit of syntax there, and it doesn't look like it typically would, the way a student would typically write it out. Some things that are on my wish list. I'd like to be able to ask students questions where their answer is an infinite set. Find all the angles where the sine is 1/2. I'd like the students to be able to list a couple of answers that get us started, tell us that the pattern repeats every so often, and then evaluate whether that set matches the answer key. I've seen a couple of presentations this week that were very good about Examiner and a function that's being loaded into the Mathematica platform that would make the answer field a little bit more robust in terms of how it evaluates things. There are certain cases like factoring questions where maybe you factor out a -1 and then write down the other factors, and we need to propose both possible ways of factoring because the two solutions are going to look differently. If you give me a list of factors without the -1 and you give me a list of factors with the -1, the factor lists are going to be different, and Mathematica is going to realize that the factors are different, but they are both correct factorizations of the same polynomial. So there's one thing on our wish list that we're hoping to get in the future. And then the final step, it turns out there are some issues here. Originally I thought, how hard can this be? Just spit it out into a spreadsheet. Turns out the database is probably the preferable way to do it, and we have a very good database. There actually are quite a few issues on the gradebook side, mostly dealing with security, but for the most part, that's on the side of the institution to work with the data security people. In terms of the instructors knowing how the students have performed and the students knowing how well they've performed, it is as simple as just recording the scores in a database and presenting that data. How are we currently using this? Our placement exam, about 7,000 students annually. We've been running it for 5 years now. We're approaching 40,000 students that have taken our placement exam. The reporting goes directly into our advisors' hands, and they can seamlessly place students into their first math class at the University of Minnesota. We use it in our pre-calculus classes currently, 1,600 students a year. And it saves our teaching assistants a lot of time. They're no longer having to collect and grade this routine homework. Students get better feedback because they're getting instant feedback. Teaching assistants can spend more of their time working with more involved questions and giving students feedback on their writing. We are using this as a way to prepare the students that are in our calculus sequence. They may need some help refreshing themselves on pre-calculus topics. This review material is available to the students. They can go back and review the topics that they need help with as they're getting ready for calculus. And it really has been a benefit to us both in the spring and this semester. We've needed to move away from in-person pencil and paper exams, and this system has given us an alternative to delivering exams to students in a reasonable way that students can show us what they know and not have to deal with a lot of technology concerns. The future. We welcome partnerships with others that are interested in these same types of things. In particular, a lot has been done in open educational resources and elsewhere to work on delivering content, but they typically are lacking the assessments. They're typically lacking the problem sets. So we would like to find ways that we can share the questions that we've written with others, and if we can share with them, crowdsource the content so that we can get a lot of content and deliver it to students. We think that would be a worthwhile project. Encouraged by some of the comments I've heard this week about the K-12 market. I really think this is a market that really is wide open for innovation. 41 states in the United States have the Common Core, and that really is the issue. K through 12 is aligning the assessments to the Common Core standards and benchmarking everything. And then there are a few other states that go off and do what they want to. Most noticeably is my state, Minnesota, which is fairly notorious for kind of going off and doing their own thing. But we have something similar to the Common Core, and aligning to those standards is something that our K through 12 schools need. And working to develop things in that field, I think, is a big opportunity. As I mentioned before, sometimes we need to ask for a specific form from students to disallow them using functions, allow them to use addition, subtraction, multiplication, division, square roots, but not allow them to use the sign function in their answer. Mentioned also before these other issues of it would be great to have the answer field be able to parse things out in terms of a variety of different answers. So if the student says this, we're going to give them half credit. If in a probability question, if they got the denominator right, we'll give them half credit. And other forms of the answer being acceptable. The ability to write infinite sets, I think, provides an interesting programming challenge. And we're busy working on solutions to that. So with that, I would like to thank everybody for attending. My contact information is here, and Randall has been monitoring the chat window here. If you have any questions about this system, please ask.
The only thing that's been posted is Namjoshi says many K through 12 schools use Google Classroom and Canvas.
Yeah, there's always the issues. One of the other big issues with the schools is they want this LMS integration. We have not bothered to do that integration yet, but that certainly is an issue for making this work large scale. Like I said, Minnesota is currently a Canvas school. It isn't all that difficult to transfer this data back and forth. So I think that's definitely a problem that can be solved with a little bit of work, I would think.
Okay. Craig says, can you talk about the marketing dispute system that you use in conjunction with the results of the exam system? Students disputing results.
Can you repeat that one more time?
Can you talk about the marketing dispute system that you use in conjunction with the results of the exam system? Students disputing results.
We haven't done anything sophisticated yet. For the most part, the students send the instructor an email and the instructor looks at the issue. Originally, when we wrote the questions, yeah, there were a few questions where the answer key was incorrect. And we've corrected those. Yeah, for the most part here, I think this is part of the philosophy behind it, that things that require certain interpretation, we expect the students to show their work in a certain way. That's not really what this system is designed to do. Anything that has some subjective evaluation to that, we leave that in the instructor's hands. This really is, can you correctly calculate an answer to this? And for the most part, there really isn't a whole lot to dispute. If the answer to this question is the square root 3/2, then that's what the answer is. So at this point, yeah, we're not trying to use Mathematica as a discussion, conversation, dispute resolution tool. We rely on our LMS and our email system to handle those sorts of questions.
Okay. Matt says, you said you use the manipulates. Are those flash-based? And if so, how do you deal with compatibility issues?
Now that you mention it, yeah, we have not used the manipulate recently. And now that I hear that question, I believe that that is exactly the issue, that I think we started running into the problems because, yes, I believe that they were flash-based. And then that was the, that was the drawback, was that we were having trouble with the manipulates working on various platforms. So yes, good question. And now that I think about it more deeply, I think that is an issue that we never did resolve. That I believe that they were flash-based, and I think we've abandoned them for the time being because of the compatibility issues.
Craig says, are students allowed to use alternative technologies during exam taking, such as calculators?
We are moving toward making as much use of technology in the classroom as possible. So we are basing more of our grade on things that they do in discussions in class, and a lesser percentage of the grade on high stakes pencil and paper exams. We do use mastery-based grading, and this I think has been one of the best features of an automated system, is that rule is very simple in my class. Your homework score needs to be 100%. If your homework score is not 100% by the end of the semester, your grade is F. You must eventually get every homework question correct. They can try them as many times as they want. They can come to office hours. They get help. Students actually get done with this stuff, but now they know what's at stake, and so they spend time making sure that they know how to do the computational stuff.
No one else has posted anything, so.
Okay, and my 30 minutes is just about up here. So once again, I would like to thank everybody for attending here, and looking forward to continuing this discussion.